Now that we understand how sound energy is converted into electrical energy through microphones, through various kinds of transduction systems, then it moves through a cable, various kind of connectors, and then what's going to happen is all those microphones are going to go into something called a mixer. The mixer is where we're going to adjust the levels. We can change some of the amplification of certain frequency ranges. We can basically add effects to the sound at that point. The mixer is where everything sort of happens in the piece. I'm going to show you the hardware mixer so we can understand the principles of how a mixer works. Once we get through the hardware, we're going to be doing the same thing in a software mixer, which all of you will be asked to download to your computers, but hopefully you'll understand how the concept of a mixer is working and what are the various components of a mixer. So here I have a very typical mixer. This is a Mackie mixer, which is a pretty good company, and this is a sort of a smaller mixer, but you can get them in various larger sizes. But the basic components of this mixer are pretty standard on any kind of mixer. So let's kind of walk through and sort of see what are the different functions of this. You're going to have multiple channels of information coming from microphones, from guitars, from synthesizers, anything that you're plugging into the mixer, and we will plug them in these top row of inputs. And you can start to see here that we have the XLR connector going here, so that would be from the microphones perhaps. And then we see a place for the 1/4-inch phone plugs, which we saw here. So the 1/4-inch phone plugs can plug in and lock into here. So any of your inputs coming from your devices, we will be plugging into the mixer along this top row. And then here we see the RCA plugs for a CD player or an iPod or anything else that we would plug in here. On the back of this, once these are plugged in, then we can assign their volume, their equalization, which we'll talk about in a second. And then usually on the back of a mixer, you will see this one has a 2-channel output. So everything that plugs into the top of the microphone, we would then be mixing to a stereo, a left and a right channel output. And here again, you see this is another XLR output. So we can send this to our recording device if we want to record into the computer, or send it to speakers for sound reinforcement. So whatever purpose, we'll be taking the final mix signal will be coming to the output. While I'm back here, you can also see the power button, which turns the mixer on and off. Beside that, you see another little switch, which is the phantom power. Remember, most mixers today will have a phantom power source on them, which if you have a condenser microphone plugged into one of these 4 microphone inputs, then you would need to turn on the phantom power for those microphones. So the phantom power only goes through these first 4 channels of inputs in case you have a condenser microphone that needs to be charged up. If you're using a dynamic microphone, then you would not need to turn that on. And it's not going to damage the dynamic microphone, it really just sort of ignores that information. But there could be some situations where it could potentially damage certain kind of devices. So I would always recommend turning off the phantom power if you don't have condenser microphones plugged into the inputs. So the microphone inputs are here. This one in particular has 4 different microphones. Each of these channels is identical. So there are 4 different ones. We have the same kind of capabilities in each one. Over here in channels 5, 6, 7, 8, 9, 10, 11, 12, you will see we only have one output volume down here. But these are designed so that we can plug in any kind of 1/4-inch phone plug that already has a stereo output on it. So if you have a stereo system, a CD player, an iPod, anything that's generating stereo information, an external sampler or a synthesizer, anything, usually a device that has a 1/4-inch phone plug or 2 of those, you plug in here. So we have a left and right channel that we plug in, but that's still 2 channels of information. So the total this particular mixture gives us 12 total channels of information, even though these 2 are designed to be coupled with the left and right inputs on them. So the first thing you do is you plug your instruments into here. You can also plug in a 1/4-inch phone plug. If you don't have microphones, you could use this to plug in a 1/4-inch phone plug. So you could have a guitar and use this. It just has a different kind of input device for the 1/4-inch phone plug. One of the most important things on a mixer, when you plug a device in this, remember that the information, the electrical information coming off the microphone is very, very low energy, because we just have a magnet in the moving coil and the dynamic, or we have those 2 plates that are charged, but it's a very, very tiny bit of electrical energy that is actually coming into the mixer. So the first thing you have to do is to run it through what's called a preamplifier. The preamplifier is going to raise that signal up high enough that we can then actually manipulate it through the mixer, and then we will send it somewhere else where it will go to an amplifier or to the speakers where we can actually move the air energy again. So the first thing is the preamp. And the preamp is a very important part of a mixer. And a lot of times people, when they buy a mixer, they look for the specifications of the preamp. That's perhaps maybe the most important part of a mixer. reason I like Mackie is they put a lot of detail into their preamps. The preamps are very good, and usually you get a lot more ability to have a higher gain. Gain is the amount of electrical energy we'll be talking about. So the very first knob we see at the top here is the determining how much energy of preamplification we apply to the signal coming in. You want to get that as high as you can so you capture as much of the preamp energy as you can, but you have to be very careful. If you overdrive the preamp, which you can do very easily, these devices have a certain limit to the capacitance that they can handle. If you overdrive the preamp, you will break up the sound. It will distort the sound and create all sorts of noise quality to the sound. And usually when I hear recordings where there is some kind of noise to the sound, it's often in the setting for the preamp is not exactly correct. If you set the preamp too low, then you don't get enough signal coming in so that you end up having to raise the output level much higher to get the correct balance. And then you get noise on that end. So what you want to do is you want to try to get your preamp signal as high as you can without getting distortion. And that's where you have to sort of check to make sure you record the sound and test it to make sure that it doesn't get too loud that you're going to get distortion. And that's, I think, in some ways the most critical part of the mixing is getting the right preamp set. Once the preamp is set correctly, then we look down here for the next set of controls. These blue knobs here are all affecting what is called equalization. Equalization allows us to divide the frequency spectrum. Remember, our frequency spectrum is from 20 to 20,000 hertz. An equalizer allows us to amplify or attenuate various ranges of that spectrum. So the simplest would be on a device that has tone controls. If you have a bass knob and a treble knob, that's an equalizer. It allows you to then take a very wide band of frequency spectrum and either amplify those frequencies or attenuate, which is reduce those. And so if you want to make the sound brighter on a treble knob, you turn the treble up, which means you're going to be amplifying all the frequency ranges in the higher partials of the overtone series. What that does, it doesn't change the sound of the instrument other than it changes its color. So it makes that sound brighter, or it makes it darker if you attenuate that. Same thing on the bass range. What we have here is a three-pole equalizer. So in this one we have a low frequency which is set at a mid-range of about 80 hertz. So when I am amplifying or attenuating using this, I have set a center frequency of about 80 hertz, and then I have some range on either side of that. And that range is being preset in the mixer. I can't control that. But what I can do is I can either attenuate or amplify everything around 80 hertz, which is going to be your low-end bass frequencies. Above that, on this particular mixer, we see a mid-range, which is 2,500 hertz. So around 2,500 hertz, I can do the same thing. So it's going to be a center frequency of 2,500 and then a sort of a range, a roll-off around that. That's preset in the mixer. And then the upper one on this one is going to be about 12,000 hertz. So I can control 12,000. So when I amplify or attenuate, I'm rolling off 12,000, but really probably up to about 14 or 15,000, and then down to about 8,000 when I move that, because it's a range of frequencies that I'm controlling. Now, this is called a parametric equalizer. This is a simple parametric equalizer. I really prefer this design over what is called a graphic equalizer. A graphic equalizer where you have a slide fader, you have multiple slide faders, you may have 20 slide faders. Each one divides the spectrum into slices. And so you can amplify or attenuate each slice of information separately. And that a lot of people do like the graphic equalizers. The parametric, a really good parametric, which this one is not a full parametric, I would have a separate control over the center frequency of this. I could move, this one is set to 80 hertz, but in a good parametric, I would have another knob which would allow me to move that center frequency up to 100 or wherever I want in that range and really specify exactly where the frequency center point is I want. And then I would have another one which would control the range of frequencies around it, how wide that spectrum is. So a good parametric, you would have 3 knobs for each range. You could set the center frequency, you could set the width of effect, and also how much amplification and attenuation happens. And so then the more bands you have of a 4 or 5 band parametric equalizer, then you really have control over changing the sound where you want. Now, equalizers are used both to help or generate the color of the sound, where you need to brighten the sound or darken it for some reason. Maybe there's some hiss in the sound. You need to try to reduce that in the upper or lower frequencies. But the equalizers are critical when you're doing sound reinforcement. Because in sound reinforcement, you're going to have to be dealing with what's called feedback. And feedback will be different in each room that you're working in. So a sound engineer, when they come in to set up a sound system, they have to be checking the room to sort of see where are the frequencies that get over amplified in that particular room. Every room is different. So they will analyze, they will take a spectrum analyzer, they will run what's called pink noise, and we'll be talking about that later, a pink noise generator which sends all frequencies into the sound system. And then they measure the output to see, are there places where certain frequencies are getting amplified because of the acoustics of the room. So what the sound engineer would do is measure those points, and then on the parametric equalizer, they would specify those frequency points and then reduce those down so that you end up with a flat response, which is what they're trying to achieve in that. Every room has a different acoustical mapping to it. So the equalizer is important both for being able to, in our studio, to be able to adjust the sound in very nuanced ways, but also in sound reinforcement, it's critical in order to avoid feedback problems in sound reinforcement. The next knob coming down, I'm going to come back to these in a second. The next knob is what's called pan. Remember, this is a stereo output, so we can go left or right. If this microphone coming in, I want to send it to the left channel, then I take my pan knob, move it to the left, and then it would only come out the left channel. If I move it to the right, then it only comes out the right. So why you would be doing this in sound reinforcement, for example, let's say you've got musicians on stage and you've got speakers on either side of the stage. So when let's say the guitarist is to the stage right, a little bit to the right side of the stage, then when you create an image, a sonic image, you would probably move the panning slightly to the right so that when the audience is hearing that guitar player, the sound is actually coming from the speaker more from the right. So it actually looks like the sound is coming directly from the musician. So we can place the sound in any part of the field, the stereo field that we want. Through this. So that's the basic information about how to get the sound into the preamp and into the equalizer, and then where we place the sound in the sonic spectrum. When we come back, we're going to talk about auxiliary send and the output channels and some of the other effects on this, which are also important.
The preceding program is copyrighted by Emory University.